Hello everyone, welcome to Saw's classes. This is Tushar Shaw, and in this video we will be continuing to solve the BHU PET 2020 question that we were solving since the last 18 videos, I guess. Okay, not 17 videos. Okay, so basically this video, like in the last video we did two questions as they were solved, but in this video we will be having only one question because this the question that is there, that is question number 19, is extremely big and would require quite a lot of time for discussion. Okay, but before going into the discussions of that of the question of the like question that is there, let us firstly discuss a bit about the BHU PET examinations. Okay, so that you may follow up with the examination quite like easily. Okay, so BHU PET basically is the exam conducted by the Banaras Hindu University for the admission in, this pen is extremely, for admission in MSc, and we are studying a chemistry course, so MSc in chemistry basically. Okay, so like this exam is held every year during the month of May, but because of this pandemic and this lockdown, it was delayed this year for 2021. So that is different issue, but we are solving the PET questions of 2020 of chemistry so that we may like get good values from them, and then after this 2021 exam is held, we will be solving that paper also. Okay, so basically this set of exam has to, like this exam has 120 question in each set of this paper, which needs to be solved within 2 hours. Okay, I know it is very extremely less as compared to the other examination that are held, but we cannot do anything because that is how things work. Okay, so 2 hours will be the total time, and for every question that you do right, you will be awarded 2 marks for that, and every question that was wrong attempted by you, we will be deducted, half marks will be deducted from you. Okay, so like it quite a fair game obviously, because normally this is what the marks distribution is in other examinations also. You, so like it will be like it is very predictable obviously. Okay, so without wasting any time, let us firstly let us look at the question pair. So let us look at the questions over here. So we did up till question number 18 as I have mentioned. So let me just like show you the question number 19, and then we'll be trying to solve it. Okay, so question number 19 is basically as I have told you that for 30 questions involve like organic chemistry of the this BHU paper, but this question basically involves a kind of like this question is basically kind of mixture of organic and inorganic chemistry combined in this question. I basically like these kind of questions because obviously they are combining concepts from different parts of the different parts of chemistry and giving it in one question, which makes them more interesting to solve. Okay, so basically, so first of all, let us start solving this question. So let me just change the color. Um, okay, so first of all, you know, need to know what are the units that are given to you. So isoprene. Okay, isoprene is this unit, CH2. Here we have CH3. Okay, so basically this is an isoprene unit. And what is Ziegler-Natta catalyst? Ziegler-Natta catalyst is basically like it cannot be defined in one single term. So let us do the like processes involved with Ziegler-Natta catalyst, and then we'll be like converting it henceforth. Okay. So basically, what you need is TiCl4, titanium chloride, titanium chloride, and what we give, firstly we give AlEt3. So what would happen is this titanium chloride firstly would be reduced to TiCl3, then the obviously if we give AlEt3, the Ziegler-Natta catalyst will be formed in an activated form. Okay, so TiCl along with the this Cl attached to its Al main metal atom. Okay, then again this Cl is attached to this its Al atom. This Cl is attached to its metal atom, and one CH2 CH3, that is one ethyl group present from the AlEt3 would be given to us. Okay, one of them would be attached over here. This is known as activated Ziegler-Natta catalyst. has started raining, but that's okay. So yeah, so this is the activated Ziegler-Natta catalyst. Now this Ziegler-Natta catalyst will be like polymerizing the isoprene unit in a very good way. So let us discuss the mechanism of polymerization over here. Okay, so uh, first of all, we'll be taking this isoprene unit, which is basically this one. This would be reacting with the active catalyst TiCl, Cl, Cl, Et. This is isoprene. This is activated Zn catalyst. Okay. So this first of all, isoprene can also be written it like this, like the conjugated form of isoprene. So CH3 will be over here, and this is the conjugated form, because obviously this can undergo conjugation again, then again this one here, this one going here. Okay, so all types of conjugation are possible, so we will be writing it in the conjugated form, because the attachment to the Ti would be there in the conjugated form only. Okay, so this would be forming, like from a tetrahedral complex, it would be forming a the TBP, that is a trigonal bipyramidal complex. Okay, so Ti, Cl, 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 we have Et over here, and we will be having this attached uh, so this part would be attached over here. Okay, this this one would be attached to the pi electrons, obviously. Okay, then this pi electrons would open up, and obviously this kind of attachment would be taking place. Okay, so let me just write it down over here. So Ti, Cl, so basically this would be going over here. So Ti, Cl, we have again Cl over here, we have Cl over here, and then we have this unit, that is basically one carbon is here. So we have 1, 2, 3, 4 carbons there. So 1, 2, 3, 4 carbons is there. Here will be with the double bond, and here will be the methyl group, and obviously after that this ethyl would be attached over here. Okay, so this is basically the complex that would be formed. Okay, again what would happen if like another molecule of isoprene is given, basically this one, with the Et group, methyl group over here. So again the TBP complex would be formed, TBP complex, Ti, Cl, 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 and this part would be there as it is, Et, CH3, and we have CH3. Okay, so again this would be forming the second product. Okay, so basically Ti, I'm sorry, let me write it over here. So Ti, Cl, 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 and we will be having Et, we have CH3 over here, and we have double bond over here, and this part would be 2 times. Okay, basically two of the molecules would be attached in the same way. Okay, again then again one this the isoprene unit will be attaching over here. Okay, CH3. So so on, so this would be like continuing, so on the reaction would be going here, and the next where like the overall polymerized product, attachment of the Ziegler-Natta catalyst would be like kind of this, Cl, and here we'll be having Et, double bond, CH3, and this part N. Okay, so yeah, so basically this would be the product that will be obtained, and if we just hydrolyze this, we will be like getting our activated Ziegler-Natta catalyst as it is, as it was there in the initially. Okay, plus we will be getting our the polymerized unit. Okay, so basically what we will be getting is so we have CH3 over here and double bond is over here N. Okay, so this is basically polyisoprene which is formed. Okay, now you need to understand that like in the question you can see that polyisoprene, two types of polyisoprene are explained in this options. So you can see that trans poly one for polyisoprene and cis one for polyisoprene is asked, and another one is the cis trans one for polyisoprene. Okay, so let us look at option D firstly. So you can see that both cis and trans are mentioned. So this option is assuming that we still have the two double bonds intact. Okay, but is that the case? No, the double bonds have resonated, and because of the attachment which are being formed, the double bond, the electrons have been distributed, and one double bond has been formed in the between. Okay, so obviously this option D here would be the wrong statement. Then we have then we will be checking the cis 1,4 and trans 1,4 polyisoprene. Okay, so is it 1,4? Yes, 1,4, because the attachment is like if we have this 1, 2, 3 and 4, then the other polymer is attached to here to the fourth one, and another polymer is attached to the one. So so 1,4 attachment is there. Now is it cis or trans? So basically for this double bond, this is one bigger priority group on rather on the left side, and here obviously is hydrogen. So in these two sides, this is the higher priority group, so they are opposite to each other, so trans product is obtained. I hope you have understood what I am saying. I am let me repeat. So for this double bond, on the right hand side we have a methyl group and this big alkyl group which is connected to other isoprene unit. Okay, so for from the methyl and isoprene unit, this side, this bond would be the higher priority, and in this side we have hydrogen and other isoprene group on this and this side. So among hydrogen and the other isoprene unit, this one would be the higher priority. So for this double bond, the higher priority groups are opposite to each other, facing opposite to each other, so therefore trans product is obtained. If they have been facing the same side, then cis product would have been obtained, but they are opposite, so trans product. Okay, now polypropylene cannot be found basically because for that you need propene as your intermediate, but that is not taken, so polypropylene cannot be found. So after all the discussion, we come to the conclusion that option A is the correct option. Okay, trans 1,4 polyisoprene is the product of polymerization of isoprene in presence of Ziegler-Natta catalyst. Okay, so I hope you have understood the concepts of polymerization, where basically from the in the presence of activated Ziegler-Natta catalyst. How Ziegler-Natta catalyst is activated, I have shown you that also, and how polymerine isoprene would be polymerizing in presence of Ziegler-Natta catalyst to give us such a beautiful mechanism and products. That is also I have explained. Okay, so I hope you have learned a lot from this video. Obviously this was a like quite a long question, so we will be moving on to the next question in the next video onwards, obviously. Okay, so thank you guys for this video. I'll see you guys in the next one.